Okay, let's begin by expanding the left-hand side of this equation. One way to do this is to apply the following formula. When we use this formula, we get the following. And now we can simplify the left-hand side. And now notice that the left-hand side of our equation is very similar to the expression we've been asked to evaluate. All we need to do is remove that 2. So let's subtract 2 from both sides of our equation, and we see here that our answer is C. This question provides us with a system of equations to solve. We have 2 equations with 2 variables. Here's our first equation, and here's our second. Now before we go any further, let's rewrite the second equation in the same format as our first equation. So we'll rearrange our terms to get the following. Now before we are tempted to solve individually for x and for y, notice that our question merely asks us to find the value of 2x minus 2y. We aren't required to find the individual values of x and y. Also notice that we can go a long way to solving this question if we add both of these equations together. Here's what I mean by this. 5x plus negative 4x is equal to x, and negative 3y plus 2y is equal to negative y. Also, 7 plus 3 is equal to 10. Notice that our question asks us to find the value of 2x minus 2y, and so far we know the value of x minus y. If we multiply both sides of our equation by 2, we get 2x minus 2y equals 20. So we see here that our answer must be E. Let's begin by rewriting our equation here. Now our first step should be to eliminate the square root sign. We can do this by squaring both sides of our equation. When we do this, we get the following equation. From here we can set our equation equal to 0 by subtracting x squared from both sides, subtracting 6xy from both sides, and subtracting 9y squared from both sides. We now have an equation equal to 0. From here we can factor this as follows. And from here we can conclude that x minus 2y must equal 0. So when we add 2y to both sides, we get x equals 2y. So our answer is C.
So here we have really big numbers. It would be too hard to figure out these squares directly and then subtract them. So here's what we're going to do. We're going to think about this in terms of difference of two squares pattern. Because of course we know that a squared minus b squared equals a plus b times a minus b. And so this is definitely going to equal 25,002 plus 24,998 times 25,002 minus 24,998. Well, let's think about this for a second. We know that 25,002 is 25,000 plus 2. We know that 24,998 is 25,000 minus 2. If we add these two numbers, the plus and minus 2 cancel, we just get 25,000 plus 25,000. That's 50,000. If we subtract them, then the 25,000s cancel. We just get 2 minus negative 2. Well, 2 minus negative 2 is just 4. So we get 4. And so the whole thing just simplifies to 50,000 times 4. Well, 50,000 times 2 is 100,000. Times 2 again is 200,000. So we go back to the answer choices. We select 200,000, answer choice D.
Set Q contains 20 positive integers. The smallest number in set Q is a single-digit number, and the largest number is a 3-digit number. What are possible values for the range of set Q? Indicate all that apply. So there can be more than one correct answer. In a way, this problem is about finding the range of a range. The smallest value in set Q is a single-digit number, meaning it can be anything from 1 to 9 because it contains positive integers. And the largest value in set Q is a 3-digit number, which means it can be anything from 100 to 999. The range is the largest number minus the smallest number. The range is smallest, let's say RS, when the largest number is as low as possible, that's 100, and the smallest number is as high as possible, that's 9. So the smallest the range could be is 100 minus 9, which is 91. And the largest the range could be is when the largest number in the set is as large as possible, that's 999, and the smallest number is as small as possible, so that's 1. So the largest value of the range could be 998. So anything between these two numbers is a possible value for the range of set Q. And therefore the right answer choices are not 75, not 90, yes 100, 275, 555, and 995, not 1000.
Okay, so let's talk about solving this. First thing I'm going to do is add 2/7 to both sides. So we have a fraction equaling a fraction. We have 4x over x squared minus 3x equals 2/7. I notice that the two numerators are divisible by 2, so I'm simply going to divide by 2 in the numerator. That will give me 1/7 on the right, and then just 2x over x squared minus 3x. Well, now, the amazing move I can do to get rid of the fractions is simply cross multiply. So if I cross multiply, I'll get 14x equals x squared minus 3x. Subtract 14x, I get 0 equals x squared minus 17x. And of course I can factor that. Now that it's equal to 0, I can factor that into x minus x times x minus 17. Well, that shows us there are two roots. One of the roots would be 0, but we're told that we have to have x bigger than 0. The other root is the root of this, which would be x equals 17. And that is the value of x. So there are a few different ways to approach this. One not very helpful way would be to solve for x, which would be some fraction, solve for y, which would be another fraction, and then put all those fractions in and try and work it out. It's much easier to think about this. We have 7 and 3 here, and we know that 63 is divisible by both those numbers, so I'm just going to rewrite 63x squared y. I'm going to write that as 7 times 9 x squared y. Well, notice I'm going to regroup these now. 7y, I know the value is 7y, and then I have this 9x squared left over. Well, 9x squared left over, 9x squared, I could write that because 9 is a square and x is squared, I could write that as 3x times 3x. So this whole expression is 7y times 3x times 3x. Well, I know the value of 7y, that's 100. I know the value of 3x, that's 100. And again, 100. So 100 times 100 times 100, that, of course, is 1 million. 1 followed by 6 zeros. Answer choice B.
Okay, we'll begin by rewriting our inequality. Now, the technique for solving inequalities is the same technique we use for solving equations. Our goal is to isolate our variable by performing the same operations on both sides of the inequality. The only difference is that with inequalities, whenever we multiply or divide by a negative number, we must reverse the direction of our inequality. So with this example, we'll begin by subtracting 12 from both sides. And at this point, we need to divide both sides by negative 3. Since we're dividing both sides by a negative number, we need to reverse the direction of our inequality. Now, once we divide by negative 3, we get the following inequality, and we see that our answer here is A. Our approach will be to first solve this equation for x, and then once we know the value of x, we can evaluate the expression 1 over x plus 2. So let's begin. To solve for x here, a quick way is to first replace 0.4 with its fractional equivalent, 2/5. Notice here that we can now find the reciprocal of both fractions to get x over 1 equals 5 halves. And of course, x over 1 is the same as x. So we now know that x equals 5 halves. Now let's evaluate this expression. Well, since x equals 5 halves, we can replace x with 5 halves. And to evaluate the denominator now, we need a common denominator of 2. Now combine these fractions, and 1 over 9 halves is equal to 2/9. So our answer is C.